about word problems is, what are they talking about? Right? Because math is another language. And so just as if you are in a foreign language class and you've got to figure out when they say that, I don't know, I've got to translate that in my brain and then think of it in my native tongue, and then I'm going to translate it back in my brain and I'm going to speak it out. And you start becoming fluent when you start thinking in the same tongue that they're speaking in, right? But for a lot of times in the middle, we're doing that whole translation process. And we need to know, we need to have a dictionary, we need to know what that is. So I have a list of, this is my dictionary of math terms. Okay, it is listed on our Google Classroom and the algebra key terms to know. This is maybe second or third page, I think, down. I've got this in the slides, so you're welcome to look it up in the slides too. But when you're in a problem and it says each or of, there's going to be multiplication involved. So when we start reading through, when you've got it on your paper, when you've got it in your book, especially with pencil, and you see those words, put those symbols above it so you can start understanding this is what I need to do. If it's saying per, we're always thinking fraction. Every time it says per, fraction, I'm going to immediately write a fraction bar. So these are the words that we have: is, equivalent, less than. She has 3 apples less than he does. That's going to be a subtraction in there. More than or additional means addition. And then we come into minimum or maximums, are often called least or greatest. It can be least common multiple, greatest common multiple. They're all tied together. Profit will always be your income minus your expenses. We always need to know that. Another one that you always need to know that's good to write down in your notes is distance will always be rate times time. So these are all good ones to have down. You can write them now or you can write them in your notes later when you're writing over. Okay? Another one that is really good to know is pay, because this always comes up on math problems. So your total pay. Your total pay is going to be your regular pay plus your overtime pay. Right? So when we start thinking big picture, what does it really add up to? If I need profit, I'm going to have income and expenses. If I've got a distance or a speed thing, if I've got total pay. So we're going to be breaking down all of these word problems and turning them into math problems so then we can actually solve them. Okay? So here's one that we're going to start with. Okay? It says the bullet train runs between Osaka and Fukuoka. Okay? So I'm a very visual person. Some people can do it all in their head. I can't do that. So the first thing I do on my paper is I'm writing an O and an F. Okay, so I can visually see what goes out. The distance is 550 kilometers, so I'm writing 550 kilometers. In math, our units matter. They're going to start mattering here as we're doing conversion rates, and I saw lots of excellent units on homework this last week. Okay, so it says when it makes no stops, so it's just going directly, it's 2 hours and 15 minutes. So we're going, I'm marking 2 hours and 15 minutes. Now, what did I do right here?
You convert it to tenths.
Okay, because right here I have 2 different units. And that gets complicated when it comes to time. So with time, we always want to combine it into one, either with a fraction or with a decimal for it. So 15 minutes, is a quarter of an hour. That's the only one. This is the one that will get people hung up all the time, that 1 hour is not equal to 100. It's equal to 60. And so we're having to change our rates that way. Okay, so 2 hours, 15 minutes. So it says, what is the average speed of the bullet train? So we are looking for speed. Well, speed is another name for rate. Okay? And if we think of speed, when you drive your car, you go 60 what?
Miles per hour.
Miles per hour. Did we just see that word? Per means?
Wait, division, sorry.
Per means division. So even, I'm gonna write miles per hour. When it says speed, I can immediately write it in this fraction form, and this already sets me up for success with my problem. So we're looking for speed. So I am looking for kilometers per hour, okay? Because it's not miles, so kilometers per hour. Okay. So speed is always going to have 2 units. We can think of it easily when we're driving our car around the rest of the world as kilometers per hour. We can also look that if we know that distance is equal to rate times time, this is a huge equation to be memorized. Distance equals rate times time, okay? Rate is another word for speed. So distance is also equal to speed times time. So what we just learned in 1.4 was how to rearrange these equations. If I want to solve for speed, what do I need to get rid of? It's the problem. I want speed all by himself. I want to solve for speed.
So you do distance times weight.
I've got to get rid of time, right? So if I change this to be an x, distance equals x. That's what I don't know, what I want. Speed times time.
To be distance divided by.
So I divide both sides by time. This goes away. And I have speed, or my rate, is equal to distance divided by time. Distance, what's a measurement for distance?
Like 2 miles.
Miles. Okay. What's a measurement for time?
Minutes. Or hours.
Or hours. Okay. So speed is miles per hour. Okay. See where we got that?
Yeah.
So even if you don't know it right up, or if you don't remember this one, we can get our way back there. If I know that I'm going, my speed equals miles per hour, I can figure out how many miles I'm going. We just don't think about it. Like you take the driver's test and they don't tell you this is a math problem. But it is.
Yeah.
You know, that's what you're functioning in all the time. Okay? So we can rearrange this in lots of different things. So it tells us what is the speed. We know if I want speed, I need kilometers per hour. Do I have units that they give me to plug into that? How many kilometers do I have?
550.
550 kilometers. How many hours?
2.25.
2.25. See, this is why it was important to go ahead and change that.
Yep.
Okay. When I reduce this, do I get kilometers per hour?
Yes.
Yep. I'm looking for kilometers per hour. That's speed. So our units can always help us know that we actually solved for the right thing. Okay, so 550 divided by 2.25 is 244 kilometers per hour. Okay.
Fast.
And then I say double check that your solution is what your question asked. So if you get 244 kilometers per hour and you go back and they say, how far did the train travel? Okay. I didn't have how far did the train travel. I solved for the wrong thing because I ended up with kilometers per hour. I ended up with a speed thing and they're asking me for a distance thing. I didn't solve for the right question, right? So in this, we're always going to go back and go, okay, they asked me average speed. Speed is 2 units. Miles per hour and kilometers per hour. Okay, that's speed. I solved for the right thing there. So with word problems, there's lots of writing on top of the problems or writing around the problems. Okay, so let's look at this one. You own a lawn care business and you want to know, so here's our question, how much money you spend. So we're looking for a dollar amount. So we better end up with a dollar amount at the end, correct? You want to know how much money you spend on gasoline to travel for out of town. So we are specifically looking for money on out of town people. So that's my question mark. money on out-of-town clients, right? In a typical week, you drive 600 miles. So this right here, I'm going to label as total miles, right? And you use 40 gallons. What is that? Total gallons of gasoline. Gas costs, so we're going to need that rate, $1.25 per gallon. So what's another way that I could write this? $1.25, so there's my money per 1 gallon, okay? So there's a unit ratio that we can use. And your truck's fuel efficiency is 21 miles per gallon, so I'm going to write this as a conversion rate. 21 miles per 1 gallon on the highway, and 13 miles per gallon in town. So this is highway. So highway is going to be out of town people, correct? And 13 is going to be in town people, okay? So a lot of information that we're gathering, okay? It can feel really overwhelming. So we start with the very simple, and then we're going to start plugging it in and breaking it apart, okay? So we're wanting to know how much money is on out-of-town people. So let's just start. How do we get them? What do we travel in the first place? We've got totals, okay? So I know that the total of what I travel is out of town and in town, correct?
Yep.
We can just start there, okay? That means that my total miles is out of town plus in town, and my total gas is also out of town plus in town people, okay? So we get a couple of different equations. So I have it written down here. So our total miles is 600. That means in town and out of town. My total gallons is 40. So that's gallons used in town and out of town. Okay, remember how we broke this apart last time? And we said, like, if I called out of town my X, then my in town would be 40 minus X. So we can use the same equation.
Yes.
So if we choose one, okay? Fuel in town is 13 miles per gallon, highway 21, and my price per gallon, okay? Another thing is for miles, how many miles are we gonna travel, okay, is our fuel efficiency times our amount of gasoline. And that just comes from our miles per gallon on the highway. So if I go, if I have 20 gallons of gas and I get 21 miles per gallon, how many miles can I go that way? So we're using rates. We're going to be using some unit rates for that, okay? So we're breaking down these complicated word problems and trying to see them a little bit more simple, okay? So right here, before we know how much we can spend on gas, we have to know how many gallons of gas we actually used for that part of the trip, right? So we know our total miles. We said our highway miles, which is our out-of-town people, and our in-town people. So if our highway miles, and I just have fuel efficiency times the amount of gas. So let's go over that again. So I said if I'm going 21, I get 21 miles per gallon, right? And I use 2 gallons of gas. What would my units do there?
Well, wouldn't it be 21 over 2?
And so this is what my truck gets, 21 miles per gallon.
Yeah.
And I used up
2 gallons.
2 gallons. So my gallons cross out appropriately, and my unit that is left is
Miles.
miles. So this tells me how many miles I've gone. So when we use our conversion factors, as we go through, your conversion factors help you with that multiplication or division. Should I be dividing? Should I be multiplying? What side should it go on? Your units have to cancel. You know, so you need one on the top, one on the bottom for it to cancel out. So if we divided by 2, we would end up with miles per gallon squared. And that doesn't help anything,
No.
right? So whenever you're unsure of what to do, how can I get my units to cancel? I've got to put my number in the right place so my units cancel. Okay? So we're going to add these for our total. Okay? So it says if you don't start with that, we just kind of worked through that right here. So our total miles is how many gallons we spent on the highway times 21 miles per gallon, right? Because that's what they told us was the highway. And how many gallons we spent in town times 13 miles per gallon. And we can see here that our units will cancel. And we would get miles plus miles, and we can add miles together to end up with miles. Okay, so initially, before we even plug numbers in, we've written this out. Okay, I've got it where all my units cancel out appropriately. So we're just going to assign one that we don't know. And I'm going to assign my variable, which I did H, for highway because that's what they asked me in the first place. And that helps me solve for the right thing. They want to know, how much did I spend on out-of-town clients?
Yeah.
My question is about highway. So we've assigned it to highway, which means that in town is 40 minus H, because the total has to be 40 together. Does that make sense? We're breaking it up using the exact same variable. So we're going to plug in our information. My total miles driven is my highway, how much I used on highway, H times 21 plus 40 minus H times 13. Okay? Is there something else that we can plug in here? Oh, that one was a little complicated. I'm going to write it on here instead. Okay? So what did we know our total miles was?
Yeah,
Didn't it say 600?
Mhm.
Okay. So 600 equals 21H plus, what do we have to do to this one?
Well, we have to
Can
get
we cancel out the gallon?
H, so we have to take care of the 40 minus the
Okay.
Yeah.
highway.
So we have a value on the outside. It needs to be, which of our properties?
Distributed.
Distributed. It needs to be distributed to both. So we're going to do 13 times 40 and get 1520 minus 13H. Okay? So now we want to solve for H. H wants to go to the movies by himself. We've spread everything out. We need to find all of his parts. What parts do we need to combine?
Well, 21H and 13.
Okay.
Well,
Negative
negative 13.
So 21 minus 13 gives us 8H, okay, plus 520 equals 600. Let me make sure that was the right. Yep, there we go. Okay. Now, who do we get rid of? We get rid of the easy guys.
So 5 minus 520.
Yeah, on both sides.
Okay. I get 8H equals
80.
80. H equals
10.
10. Okay. Now, had we picked the other one, we would have to subtract it from 40 to find the right one. So now we say H equals 10. What did I assign to H? This is why it's always important to write down what you're doing. Whatever. What did I assign to H? H equals 10. Okay, so I'm going to put it up here. H equals 10. Okay, that means it's my highway gallons. Okay? So this is highway gallons. Out of town people. That's what we wanted. So we used up 10 gallons there. And our cost per gallon was
$1.25.
$1.25. Okay. So let's look at the units here. 10 gallons. So we're just going to double check with our unit. 10 gallons times $1.25 per gallon. Do my units cancel?
Yes.
Okay. And I'm left with what unit?
Dollar.
Money. Okay. Then they wanted our answer in money, right? So again, we can do this. So we did $12.50.
That'd be nice.
Wouldn't that be nice? Okay.
Seriously.
So really complicated problem initially. We broke it down and started, and sometimes you're like, I don't even really know the formula that I actually need. So we start with, what do we actually know? We know our total is out of town and in town, okay? Then we're gonna break it down more for that. What do I actually know about out of town? Well, out of town is how many miles I drive times how much I get per mile, right? And in town. So when we can take each section, even though we didn't know how to make this equation right off the bat, we were able to create this equation by saying, what do I already know? And any questions on that one?
Don't think so.
Okay. The hardest part of word problems is figuring out what are they asking. I'm gonna skip through this. So that's if you go back over it. I have it all written out for you. Oh, this is supposed to be a different one. Okay, so this was another one. Central Pacific. I must have copied it over. Okay, so example 4 in your book says, if you have it, if not, it says Central Pacific averages 8.75 miles of track per month. Okay, so right away we've got a rate. When we hear that rate, so that's page 35. Go ahead and turn to 35, and we'll walk through it. Okay, and you can write this with your notes as you go along too. So remember those rates, rate, ratio, speed are all just the same words for a fraction. They all mean the exact same thing. Right? So as we walk through this, we're going to start writing down what we do know. So they average, Central Pacific averages 8.75 miles of track per month. So right away I'm writing CP 8.75 miles per month. We're writing it as a fraction. So that's the very first thing we're going to write on our paper. Okay. Then it says Union Pacific averages 20 miles of track per month. So I'm writing down UP 20 miles per month. These are our conversion factors or conversion rates that we're going to use. Okay. It says the photo shows the two companies meeting in Promontory, Utah, as the 1,590 miles of track were completed. So right away I know my total amount of track was 1,590 miles. So I'm writing that down. So we're just getting information out of the book onto our page in math terms. Okay, so now I've got two fractions and a total. Okay. It says, when was the photo taken? Okay, so they have a when is going to be a time issue, okay? And then how many miles of track did each company build? Right? So they are meeting. So right away, we're going to ask this. When did they meet? So we're looking for a time. How much track did each of them do on the process? Well, what do we know initially? We had this total. Let's kind of break it here first. We know that our total here is our 1590. That means, let's choose, who did I choose? CP. Okay, CP is going to be our unknown. And then Union Pacific will be the rest of it. So if CP did who knows how many tracks, then Union Pacific did 1590 minus unknown value of track. Correct?
Yeah.
All right. It also says, we're going to use the picture on the side. It says, in 1862, so we're starting, 1862, these two companies were given the rights to build a railroad. They began, Central Pacific began in 1863. Okay, so that's actually when they started, 1863. 24 months later, Union Pacific began in Omaha. So here's Central Pacific start. Okay, 24 months later is when they start. So when did Union Pacific start?
1865.
1865. Okay, so we're looking at some differences there. Okay, and so they're wanting to know when they meet. Okay, so let's work through this. So the first thing that we know, distance equals rate times time. This is a very simple one that we're always going to use. Okay, so the total track is equal to the total, so distance here, distance is in miles. So we can use our units for this. So we're looking for miles. Everywhere that we see miles, we can replace it with rate times time. We're substituting here. So if our total track equals the miles of CP plus the miles of UP, right? Everywhere I see miles, I can replace it with rate times time. We're just substituting. Okay, so this is where we start. We go, what do I know about miles? Miles equals rate times time. Right? I know miles equals rate times time. So that means I have the rate of Central Pacific times the time of Central Pacific. So again, now we're just substituting again, taking what we know. Rate of Union Pacific times the time of Union Pacific. Plug it in. So now, do I know any of this information? Can I plug in any of this information? Well, my total track I know was 1590. They gave me the rate of Central Pacific was 1.75 miles per month. Okay. Do I know how much time it took them? No. So I'm just going to call that, we call it T. I called it T here. It took them T number of months. Okay. Then I have the rate of Union Pacific, 20 miles per month. And how much did they do? Well, they spent, because they ended on the same day, correct? But they started 24 months later. So whenever Central Pacific started, Union Pacific started at that time minus 24 months. And this is where our units come in. We're making sure we're all in the same. One's not in years and one's not in months. We would need to switch. Do you see where the T minus 24 came out?
Where did 24 come from?
Well,
It said they started 24 months later.
Yeah.
Okay, so if you start in January of 1863, how do I get to January of 1865? I've got to subtract 24 months from that, okay? So, now we can plug, we've got all of our information, we can plug it in. Our months canceled out and I ended up with miles. Our months canceled out and I ended up with miles. So now I have miles equals miles plus miles. Can we add all of those units?
Mm-hmm.
Yeah, they're all the same. So we have 1590 equals 8.75 times T. We've just broken it out into 20 times T minus 24. So we took all of our words and our units so that we could get our equation that we know how to solve. But initially, if we just plugged in all of these numbers right away, we might get a little confused or not know exactly where to plug the numbers in. Okay, so now we're gonna solve for T. So first order, T wants to go to the movies. Spread them all out, distribute. Distributed the 20 throughout. Okay, second rule, find all of his parts. We're adding our T's together to be 28.75 T. Third rule, get rid of the easy guys. We're gonna move 480 over and get 2070 equals 28.75 T. Fourth rule, get the monkey off his back. We're dividing and we get 72. T equals 72. 72 what? Months.
Yeah,
72 months. So this is where we get an answer and we go, here's our answer. Okay, is that what they asked for? What are we finding? We need to know what we solved for. 72 what? 72 months. When we go back up, we saw that T right here was in months. Okay? So, let's answer their question. What did they want to know? When did they meet? Well, we started with the guys who started first, right? So we can use that 72 months. They met 72 months after they started. Right? So if they started, how many years is 72 months?
6.
Yep. 6 years. So if they start in 1863, they finished
1869.
in 1869. Okay? Then it says, how much track did each of them do? Right? I like to do,
Track per month is that what you have to find out?
Uh-huh. Yeah. So how much track do they do? Because now we know how long. So we've got, I like to do my conversion factors in this little chart. I write it like this, and then I can add as many as I need to put my ratios in. Each one has to be the number one, technically, because when we're converting, okay? But it keeps all of my units and everything in order, so I'm gonna do this. So, what did I started? I know that they started in 1863, they finished in 1869, okay? So, we had 8.75 miles per month is what Central Pacific did, and they worked for 72 months. So if I was gonna do my chart, I would put it in like that. I've got my months cancel out. 8.75 times 72 months means that they did 630 miles. Okay. Now, if I know that my total was 1590, I can just subtract to find out what Union Pacific did.
Yeah.
Right? I can also do 20 miles per month times how many months did they work? 72 minus 24, right? So they only worked 48 months and gives me 960. Now these two numbers should add up to be 1590. That's our double check to make sure that we did it correctly. All right? Any questions about that one? Okay. I know, they throw some real hard ones in right away, especially as, you know, our big goal is for you guys to ace that ACT test in this, right? Is being able to decipher what are they asking me in these word problems. They won't always be this hard, but they can be a little complicated. This one you might want to write down, have for your notes. We're going to do this last one. So again, it's a rather complicated one. I'm trying to get your brain involved for this, and then we're going to hit some inequality things, okay? So let's think through, what do we know? What do we not know? How can we work towards finding an answer? Okay, a fire truck is called to a scene. 3 minutes later, a second truck is called. So remember when we talk about those later or less than or whatever, we've got a subtraction. So somehow I've got a subtraction sign somewhere, okay? The first truck averages 30 miles per hour. Okay, so here's our rate. The second truck averages 60 miles per hour. They travel a total of 12 miles and arrive at the same time. So we're looking at something similar to the train track one that we just did. So we've got, here's a house. We've got truck heading this way, truck heading that way. Okay? So they travel a total of 12 miles. They show up at the same time. One truck is going 30 miles per hour. The other one is going 60 miles per hour. Okay? Or maybe they're coming, let's do it like this. They're leaving the fire station. So this one's gonna end up passing this guy, probably, or showing it, okay? How long from the first call do the trucks take to arrive? So they show up at the exact same time. And how far did each of them travel? So what are all the things that we know? Lots of information in this one, okay? What do we know? We are gonna call the first truck's time T, okay? Because we don't know how long it took him. Okay? We do know that distance equals rate times time. We know his rate. We don't know the T, and we're trying to find out a distance, okay? We're there. Truck 2's time is going to be however long it was minus 3. Correct? Okay, he left 3 minutes later. Truck's 1 speed is 30 miles per hour. Truck's 2 speed is 60 miles per hour. And the total distance that they travel is 12 miles. Okay. So before we move, we're gonna go back and we're gonna put a unit here. Truck 1 time is in T minutes because we subtracted 3 minutes. So where are we gonna have a problem? Right away. How are my units gonna shake out? Do we have an error? Do we have a hitch somewhere?
Well, we know that the second truck didn't leave the fire station until 3 minutes after the first truck did.
Okay, correct. Okay, so we wrote that down here. And then I have speed in miles per
hour, so that's time.
Yep.
Okay, so I've got some time units that are in
Minutes
and some time units that are in hour. Okay, so we're gonna have to convert something at some point. Okay, so right off the bat we can convert it, or we can convert it whenever it becomes a problem through it. But when we're going through and we're looking at distance to end up with miles, I know I'm gonna have to cancel out my time somewhere. Well, I can't cancel out minutes and hours, okay? So what I suggest is right away, let's switch this to miles per minute. Okay, so how would we switch this to miles per minute? If we have 30 miles per hour, we know that they're in, our units have to cancel, so 1 hour is 60 minutes. So here's our conversion factor. This is equal to the number 1, right? Because they're equal to each other. So I'm just multiplying times 1, which means I'm not really changing anything. Which means I end up with 30 divided by 60, or 1/2, 1 to 2, miles per minute. Okay. So I can change his speed to 1 mile for every 2 minutes. So let's convert the other truck. He goes 60 miles per hour. So what is his speed?
It'd just be double. Should be 1 mile per minute.
1 mile per 1 minute. Okay? So now, as we start putting things together, we have conversion factors. We have our units match up. Right? Okay. So, erase my things so we don't get mixed up. Now, because we know that distance equals rate times time, we can use this just like we did before to substitute it anywhere we see it. Okay? So our total distance is equal to the distance that the first truck, I did D1, plus the second truck. Correct? Which means our total distance is the rate of the first truck times the time of the first truck plus the rate of the second truck times the time of the first truck. Second truck. Second truck, right? So all we've done is just substitute. Total distance was you plus me, and now we've just substituted these guys in for distance. We're doing some substitution here, okay? So let's plug in our values that we now know. We have this. What was our total distance? 12 miles. Okay? The rate of the first truck here, and I still have it in the 30 miles per hour, we know that it is 1 mile per minute, right? That's down here. The rate of the second truck is 1 mile per 1 minute, okay? So the first truck went T number of minutes. The second truck went T minus 3 number of minutes. So now, we got all that nasty information in this really great equation that we can solve, okay? So sometimes it involves that substitution. We start really simple, we substitute for what we know. So how do we solve this one? Okay, so I just rewrote it again. So we have, let's go back. 1/2 times t is going to give us 1/2 t, or t over 2. Okay, this is just 1. So basically I just get t minus 3. Okay, so I had my t over 2, that was my 1/2 times t, and then our t minus 3. We've just multiplied out that. So 12 equals, we're going to combine, we spread them out, so we're going to combine our parts. 1/2 plus 1 gives us 3/2. We're going to leave it as a fraction. I like working with fractions better than decimals.
Other way around.
It depends on what you're using. So we're going to get rid of the easy guys. We're going to move our 3 over, and we get 15 equals 3/2 t. Then I'm going to multiply times the reciprocal, which means I multiply times 2/3. Multiply times 2/3. Because we can't divide by a fraction, right? So, or we could also cross multiply, because this is really 15 over 1. So either way, we can get 30 equals 3t, then divide by our 3, and we get t equals 10 minutes, okay? So it took the first guy 10 minutes, because that's what they were asking. Then, how far did he travel? Well, distance equals rate times time. His rate was 1 mile for every 2 minutes. He went 10 minutes. So he went 5 miles. Okay, so then same thing. If he took 10 minutes, the other guy took 7 minutes, right? Because he left 3 minutes later. So it took him 7 minutes. So he went 7 miles. And then did those add up to 12? 7 plus 5? Yeah. So we double checked we have all of our right answers. You might see this one on your test. So that's why I wrote it. Know how to work that one out.
Is that one on the book too?
It's, I think it is. I think it's in it. Okay. So, word problems. As you work through 1.5 and you're working out the word problems, please call me if you're like, I'm not sure what to do with this word, or did I set it up properly? It's all in setting it up. Once you get it set up, they're pretty easy to solve. It's just how do we decipher? It's really like looking at a treasure map or figuring that out. Okay, so the rest of the chapter, we're going to spend a little bit of time and we're going to go over 1.6 and 1.7, which deal with absolute value and inequalities. Okay, so a couple of new-ish reminders of what we learned in algebra. So when we deal with an inequality, we are looking at not just one answer, correct? So in math terms means not, in, or ir. IR is the not. So it's not equal or things that aren't, you're not setting it with a true equal sign. We know that when we write inequalities, we're dealing with less than or greater than, or less than or equal to, and greater than or equal to. So now, when we deal with an inequality, we go from one specific answer to a broader range of answers when we have them, okay? So inequalities are solved exactly like equalities, with one exception, and that involves a negative number. So if we are adding or subtracting a number across a side, it doesn't change it at all. That's solved all the way through. It gets to whenever we have to divide or multiply by a negative number, and that it switches the direction of the sign. So you probably saw that in Algebra 1, but if we are doing this, so if I have negative 3x is less than 9, if I am dividing both sides by negative 3, this sign has to change. So I have x is greater than negative 3. So the numbers work exactly the same. It's just the direction of the sign. Now, if I have x minus 3 is less than 9 and I'm adding it, it doesn't change anything. Less than 12. Okay? But that multiplication and division, so whenever you have that negative that's going, or if I decide that I want to multiply something across, and I have, and I multiply times negative 2, I'm multiplying both sides times negative 2 or whatever, like we're going to switch that sign. So it comes whenever you're going to see it when you're dividing or when you're multiplying by the reciprocal, that's a negative. So we always need to switch that. That's important for the next lesson, whenever we talk about absolute value inequalities, you'll see why it looks a little different and what we're doing with switching that sign. So it comes into play for that one. Okay, so if you'll get out your absolute value or your inequality worksheets, and this will go in your interactive notebook behind. Did you get your other ones put in? Yeah. Glue them in. Okay. So this one will go in right here. You put it under 1.6. It's a little fold. So once you cut it out and put it in, you can fold it out. Okay. So things with inequalities. Inequalities have to include all of the values that can make it true. So again, we've gone from it being one single number to now there's a whole bunch of numbers that could answer that. Okay, so we've got the less than or greater than. When we graph them, anything that does not include the equal sign is an open circle. Is this coming back?
Yeah.
If it has an equal sign, that means it actually includes that point. And so we close in the circle on it. Okay? And the reason is because if it's not equal to, it can be as close as it can be, but it can't be exactly that. So we have to identify it as it's as close as it can be, but it's not that.
Yeah.
But it's not that. Okay? Okay, so those are the equal signs, so we're just going to include those. So when we solve them, exactly the same thing, unless we have to switch directions for that negative sign. All right, so let's look at this one. 2x plus 1 is less than 6x minus 1. Okay, so first thing, number 1, are they all spread out?
Yes.
Yes. Step 2, find all of his pieces. So I move. Some people like to only have their values on the left side, on the right side, and they don't mind working with negatives. I just don't like working with negatives, so I'm always moving the small number around so I can be a positive. So I move my 2x over, so I am left with 1. My sign stays the same. 4x minus 1 at this point. I'm going to move that 1 over. I get 2 is less than or equal to 4x. I divide by 4, and because I'm dividing by a positive,
You switch it. Or you don't.
everything stays the same. Everyone's all happy. So you can kind of think in that way. It's a positive term. Everything's good. Just leave it all the same. Okay, so we divide by 4, and I get 1/2 is less than or equal to x. Now, the way in which you write this is personal preference, I will say. My personal preference is, because I'm visual, is that I like my sign to be pointing where the lower number is on the left and the bigger number is on the right, because if I'm looking at a number line, it all lines up in the right order. So in this case, so I'm going to have my less than is pointing to the right direction. Okay? So I would put 1/2 down. 1/2 is less than, that means my x is everything bigger towards that direction. It's equal to, so we have filled in the circle. That means I can pick any, I could pick 2, 4, 104. All of those are solutions to this equation. Right? So let's look at this one. For number 1, is it all spread out? Yes. Does he have any extra pieces to find?
Not really, no.
No? Okay. So we're going to get rid of the easy guy and move that 3 over. Do we have to change the sign when we are adding and subtracting?
No.
Nope. So we just move them over like a normal equal sign, and I have negative x is less than negative 2. So to get the x by itself, I need to either divide by negative 1 or multiply both sides times negative 1. In that case, so I've got a negative here. Things are not okay. My sign switches from less than to greater than. When we keep it in a chart and in an order, it keeps us from moving our variables around, and we don't lose the wrong direction for that. Okay, so now I've got x is greater than 2. If I'm graphing this, I would write 2 is less than x, which means that I'm going to write 0 and 2, because when you're doing them for me, you don't have to write any of the other ones in between. Okay, so I've got a 2. Is it included? Nope.
It's not equal to.
And then x goes everything bigger than that. 4. Okay. Okay, so compound inequalities. Now we're going to add them together. So we always take something simple and then we make it harder because we combine it, right? So with compound inequalities, the things I like to say is and is like hand, and we hold hands, right? So you like to hold hands. Once you get a girlfriend, you like to hold her hand, right? Your mother loves for you to hold her hand. So and is hand, that means we're together. It's the part between us if I'm holding hands with somebody. So and is going to be a joint union with it. Or it's you or me. You're going to have to choose. So with or, we can never have the same thing, because you cannot be 4 years old and 62 years old at the same time. You are either, if you're going into the zoo and you can get a child's ticket or an adult ticket. Well, I can't be 4 and 62 at the same time. I can be 4 or 62, okay? But I can be 43 and a girl at the same time. Okay, so when we think about it, what ones go together, what ones go opposite? I always think the less than looks like a holding a hand together, so it's when we get to the other inequalities, it's the and one, but and is hand, the parts between, or opposite. It's you or me. You're going to have to pick for that. Okay? So, and will always be in the middle. The x, he's holding hands between the -2 and the 1. Right? And so we're going to graph our numbers exactly the same. We put our numbers on the chart. We leave our inequalities off, and we're just going to put our numbers. So -2, I'm going to mark it. I'm going to mark then I'm going to mark 1. Now my inequality tells me what to do with that number. This one tells me I need to fill it in. This one tells me it needs to be an open circle. Okay? Now x is everything between them, so I'm going to fill the line between them. So we can read our inequalities with little steps of what it tells us to do. It's going to be in the middle. So if we solve this one, the thing about inequalities with ands is that they can be done separately. I could rewrite this, so here's my first one. -12 is less than 3x minus 3 is less than 15. This can be rewritten as two separate inequalities and solved as two separate. It could be -12 is less than 3x minus 3 and 3x minus 3 is less than 15. It is perfectly acceptable to solve them as two separate ones, if you would like. Okay? So if we solved it separately, I would need to add 3 and add 3, correct? And on this side, I'd also need to add 3 and then add 3 if I was solving them separately. So what we can see is that whatever was in the middle affected both sides. So when we are solving them as one, and we haven't separated this, whatever we move from the middle affects both sides. We have to do it equally. Remember, math has to be equal. I can't just pick one side. This is where the error comes. If I've moved it over, well, it doesn't exist anymore. We've got to move it to both sides. So when I get rid of this 3, I have to move him out to the left. I also have to move him out to the right. So now we have a 3x left in the middle, and I have -9, and I have 18. So he's affected both sides. Okay? Same thing when we are dividing. Once I moved over here, I would divide by 3, and I would divide my left side by 3. If I was solving this one separately, I would divide by 3, divide that side by 3. He's affected both sides, so we have to do it on both sides here. So we're going to have -9 divided by 3 gives us a -3. The sign stayed the same because my initial start didn't have a problem. He was positive. Okay, it's okay that we ended up with a negative answer, but it didn't come from the division process. 18 divided by 3 is 6. Then we get to check, does that make sense? We're going to go left to right, smallest to greatest, negative numbers to positive numbers. -3 is less than x is less than 6. Your signs for and will always face the same direction. If you end up with opposite facing signs, you've made an error or it is not an and problem. Okay? So if you end up with this one is greater than that way, there's a problem. It can never be written like that. Never, ever, ever write a variable in the middle of two opposite signs. We cannot write OR problems as one unit. They have to be two separate inequalities. Right? So it means that our solution overlaps. We had -3, we're going to plug him in first. 6, we're going to plug him in. Do we have equal signs? No, so it's just a circle, and then I'm going to fill in all the spots in the center of that. Okay, so when it's OR, it's on the outside of it. They will not overlap. You will have no holding hands. They will have nothing to do with each other. Your graph should look like two arrows facing away from each other. You can think of like, talk to the hand, don't want to talk to you, right? So in this case, we have one equation or another equation. They are not combined. It starts as 2, it ends as 2. So we work through normally, and we get our answers. We're going to graph our answers separately, but on the same graph. So x is less than 1, So I've got 1, x is less than it, x is greater than 4, is greater than that. Okay? So those are always going to be written separately. Okay, so now we're going to combine a word problem and an inequality. You are a state patrol officer who is assigned to work traffic enforcement on a highway. The posted minimum speed is 45 miles per hour and the maximum is 65 miles per hour. So if I have a number line and I have 45 and 65, you are allowed to drive within that space.
Yeah.
So if we call this x, right? X is going to be in the middle of those, correct? Yeah. Okay, so here's a way that we could write out that compound inequality, okay? You need to detect vehicles traveling outside. So what is X not allowed to be? You are not allowed to be over here or here. So you cannot be less than 45, and you cannot be greater than 65, right? So these are the two conditions that exist. You are looking for people who are less than 45 miles per hour or greater than 65 miles per hour, okay? So that's a good way to word it. So if they are, oh, it was for kilometers. So there's a couple different things. So then we would just use our conversion factors if they want it in they want to convert this to kilometers per hour. So we start with 45 miles per hour. Our conversion factor is 1 kilometer equals 0.621 miles. So that's a conversion, and usually you're given your conversion factors. So I want to cancel out my miles, so I end up with kilometers, and I get 72.5. So they were just asking for this one to convert miles per hour to kilometers per hour. This is how we can assign our inequalities outside of that. Okay, so those should be pretty straightforward for your homework. Questions for that one? So let's look at absolute. Okay, so let's fill in your sheet. So it says, and statements will always overlap.
Wait, which?
Your little compound inequalities. It looks, yep, this one. So it will fold and go in your book. So we're going to fill in this part right here. And statements will always overlap. If it does not overlap, it has no solution. Okay. The bottom part is, or statements will always have a solution, and only one of the two inequalities have to be true for there to be a solution. So the upper part where it says the solution to an and inequality is always in the overlap, that case 1, your solution is infinite, right?
Yeah.
Case 2, you have a certain set. You would have just one set of a solution. In case 3, do you even have a solution? You got 2 arrows going in opposite, right here, 2 arrows opposite directions, and the overlap. It has no solution. Okay. So the bottom part for case 1, it's an or. So again, it's an infinite solution. Case 2, it's okay. You get a solution for that one. You would have a single set of a solution. In case 3, you still have a solution because it's or. It can lie in either or of those. So there's a little section that's missing, but it would be 2 sets of a solution, right? So it might be negative infinity to 3, and then 5 to infinity, in that way. So it can be in either.
It would be going the opposite direction.
Yeah, so this is the x going that way, the x going this way. It's just not 4 for that one, okay? couple of things to note when you are writing set solutions. Okay, if it is included equal sign, you use a bracket. Okay, if it is not included, you use a parentheses. Okay, so
Okay, so if it's
included
equal
equal
to-
sign, equal to is a bracket, not equal to is simply a parentheses. Infinity is always a parentheses because it never has an actual ending. So you can think about that like equal sign is an actual ending. You know where to stop, it's a brick wall. When you're not quite sure where to stop because it's not equal or it's going to infinity and it's always changing, it's a parentheses. Okay, so absolute value, you have an absolute value sheet. Okay, that has a little box on it, and then the other one is a practice sheet for homework. That'll be your homework sheet to do. Okay, and it'll go in there. So the definition of absolute value is the distance from zero. So where we have been looking at properties, identities, inverses, things, now we're just looking at a distance. Like, how far like, I could say, you are the same distance from the projector as you are. Same distance, but you're in different directions, but it's the same distance. Okay, so that's all absolute value is, the same distance. It is never, ever, ever negative. So on there where it says facts or characteristics, right, always positive. Or you could write never negative, either way. Definition is the distance from zero, or distance from the origin. Okay, an example is -6 and 6. Right? They are both 6 units from 0. Now I'm going a different direction, but we're just looking at the space. So geometrically, you could think of this if you took your ruler and you measure it like you're just going around like on a unit circle. You're going different directions, but you're the same distance all the way around on it. Okay? So on the bottom it says, remember, absolute value is not the inverse. We like to think of it in that way, but it's not necessarily the inverse. It's actually looking at the distance for that. Okay? So absolute value equations are always a compound statement, right? Because there's 2 options for the inside. And something that I want you to maybe change the way that you have thought about this or even maybe been taught for is often you will have -4 is equal to 4 and negative, like, they'll write it like this, okay? And then whenever we come to the inequalities, they'll say just put the negative number over here, okay? So, or if you say the absolute, what are the values that we could pick for 4? We could have 4, or we could have -4, right? Okay, but what it's really saying when we have an x on the inside, like if we don't know what this value is that the positive value of this x equals x, and the negative value of this x turns into x also. So we have a negative, we can put a negative number in here, or we can put a positive number in there, both directions, and they both end up positive on the back side of it. Okay? And that makes a difference whenever we are doing the inequalities portions. Okay? So, regularly, absolute values work like parentheses. They are not a parentheses, so you cannot distribute into an absolute value like you could distribute into a parentheses. It is not a parentheses in that form, okay? It is its own. You have to work everything inside of it first, and once you pull it out, it goes away. So once we pull out this 9, it no longer has absolute values. Like in this case, -9, we've pulled it out as a positive. Like it doesn't have the absolute values anymore. So once we take care of it, those parentheses, those boundaries there, they go away for it. Okay? So we can work them as regular equations. We just have to work everything on the inside first and then replace it. Okay, so in this case, we've got 2x minus 5 equals 9. Okay, so we would pull it out, and we have, add our 5 to both sides. We've got 2x equals 14, x equals 7. Okay, now, in this case, this is the positive version. Okay. I can also say the negative version of this, negative 2x minus 5, is also equal to 9. Okay, so this is where it might look a little different. I, for myself, will often write this negative on this side first. What you've seen is this, write it, it's equal to the positive version, and then it's equal to the negative version of it. It is because we've just multiplied times -1 and then moved it over here, and but this is really step 2 for it. Okay, so I've got the positive version is equal to 9. I've got the negative version is also equal to 9. Okay, so now I have 2x minus 5 equals -9. When I add 5, I get -4, and x equals -2. So we have 2 separate answers for it. Okay. Often we have to go back and make sure that our answers worked, that it wasn't an invalid solution. When you're dealing with fractions and you have a variable in the bottom, one of these solutions might give you a 0 in the bottom, and so then it's not actually a solution. Okay. So when it comes to inequalities, this is where that negative makes a difference. When your sign is less than, immediately you're going to end up with an and. So that's the holding hands. When your sign starts as a greater than, you're going to end up with an or. 2 separate options, or inequality. There. When you solve absolute value equations, this is where the negative part makes a difference. Okay, so we have 3x minus 2 is greater than 18. Here's our first one, because I need to have both the positive and the negative version of it. So my positive version says 3x minus 2 is greater than 18. My negative one says negative 3x minus 2 is greater than 18. Okay, so we write it exactly the same, positive version, negative version. What happens when we multiply times this negative, or divide this negative over? It becomes a negative 18, but what happens to the sign?
Oh, it has to flip.
It has to flip. Okay, so here's where the error can happen with those inequalities, is because that sign has to flip. Because we didn't just make that 18 negative. If we always think it's equal to the positive version and the negative version, we could just say it's greater than 18 and it's greater than negative 18. But it started with the negative on the left side, and we've had to divide it out so it flips that sign. So there's the hang up that you need